Hello and greetings. Today I'm going to present you my video presentation of my progress report titled The Development of Biochar Activated Carbon from Bamboo as an Absorbent using Self-Sustained Carbonization with Controlled Chemical Activation for the Ammonical Nitrogen Removal. My name is Sharifana Azra binti Hamid. My supervisor is Professor Madhya Dr. Jufri Idris, and my co-supervisor is Dr. Technologist Siti Katina Abdul Karim. First of all, I would like to introduce you to our background, where my study is about water, where here water and biochar. So here in the rapid world population, so the usage of water for agricultural purposes have been increased to meet our demand. So the population of Malaysia now is at 33 million. And due to these agricultural activities, the presence of this ammonical nitrogen in water bodies is quite worrying, where it's the second most produced chemical because of 80% of this total utilization as nitrogen, they're using it as a fertilizer. And throughout leaching, runoff, precipitation, it caused a process called, not a process, something that called eutrophication, where in freshwater and marine ecosystem, where it resulted in ecological disaster. And here, as you can see in the this is the normal wastewater treatment, where we do the filtration, straining, sedimentation, aeration, then coagulation or population, and then disinfection and fluoridation or chlorination. So here, as a solution, we want to use this biochar for ammonical nitrogen removal in water bodies, where here, as you can see in the red box, the absorption happens here, where they materialize this biochar application as an absorbent. So activated carbon here is produced from this environmental waste, where you have high carbon content. And here, the lignocellulosic and coal materials has been used as raw materials that are planned for manufacturing of activated carbon. Okay, so because of this large surface area, poor volume and rich organic carbon and mineral components, this what you call activated carbon, if it's made from waste biomass, is also very abundant. And here, people use materials such as coal, coconut shell, wood, sugarcane bagasse, soybean hulls, and nutshell for the biomass, for the material. So the preparation of this activated carbon, they have two basic steps that they need to maintain: the carbonization and activation. So here we have a process called pyrolysis or gasification, where at a higher temperature and in an inert atmosphere, they will produce biochar. So you have to see the temperature, the heating rate, the nitrogen gas flow rate, and the residence times are a very important parameter in this stage. So to achieve this biochar, uh, when this biochar, they reveal a low absorption ability, we need another process called activation process, which is essential for improving the pore and pore diameter and surface area. For the types of activation, we have four types of conventional activated carbon. The methods to activate this carbon. So first we have physical activation using nitrogen gas, carbon dioxide, and water. We heat it up with this gas. And then chemical activation, where we use chemicals such as phosphoric acid, potassium hydroxide, and zinc chloride. And then we have physiochemical activation, where you use heat and applied chemical to it. And then we have microwave assisted activation, where the microwave radiation here is used to activate the carbon. The problem with the conventional activated carbon is that although there are abundance of it but one of it is the cost-intensive regeneration process for here. So the costing of making this activated carbon is an issue. So we'll try to find we try to solve it by using a very we call less costly methods. Okay, so let me introduce you to my proposed flow. Okay, first the bamboo was cut and dried 3 weeks, and then we cut it into 1 feet length, okay, and put it inside this self-sustained carbonization reactor. So you will get this bamboo biochar, and we use this bamboo char for the control chemical activation. What I meant by control is that we do series of temperature and series of time to chemically activated the bamboo biochar inside, and then we will choose the best bamboo activated carbon by comparing series of the characteristic analysis. Okay, and then we use the best bamboo activated carbon for ammoniacal nitrogen absorption jar test, where we also have 3 parameters. And after we get the best parameter, we will test the bamboo activated carbon with the agricultural wastewater. Okay, the status of my major research for my problem statement. Okay, first one is that I want to see the effectiveness of this bamboo activated carbon on removing this ammoniacal nitrogen in the real wastewater, because here in my research I'm doing it for a jar test where we optimize the temperature, mass dosage, and initial concentration. And the problem number 2 is that you want to also to study the performance of optimized bamboo activated carbon in terms of the pH, COD, BOD, turbidity, and ammoniacal nitrogen in terms of percentage of reduction or percentage of removal. And the third one is that we want to study the bamboo activated carbon, the characterization of the optimization. We want to see the retention time and the temperature for this chemical activation with phosphoric acid impregnation, where we'll do it with a self-sustained carbonization technology. We will see that if the self-sustained carbonization technology can reduce the the activated carbon cost, okay, because it will reduce the the retention time and the high energy in order to get the optimized one. Okay, for my research objective, okay, I have 4 research objectives, where the first one is to evaluate and characterize the raw and the bamboo biochar that are produced by using self-sustained carbonization in terms of the ultimate, proximate, and surface morphology. And then the second one is to evaluate the activated carbon characteristics that are produced from this chemical activation at a different temperature and retention time using this acid impregnation. And the third one is to study the kinetic modeling of Langmuir-Windisch absorption capacity by using produced activated carbon for ammoniacal nitrogen removal in a single synthetic ammonium nitrate solution at different temperature, mass dosage, and initial concentration using a jar test experiment. And lastly is to evaluate the performance of optimized activated carbon for treatment of plantation agriculture wastewater in terms of the pH, COD, BOD, and the turbidity. In the scope of my study, we'll have the study of bamboo as an activated carbon as absorbent, then the bamboo biochar production by self-sustained carbonization, and the production of activated carbon by chemical activation. So the best one will be studied for ammoniacal nitrogen jar test, and from this one we will produce a kinetic modeling of absorption, and then lastly we will do the real application of ammoniacal nitrogen removal. As my literature review, I want to introduce you that bamboo biochar have a unique properties of large surface area, high porosity, many functional groups, high cation exchange capacity, and stability. And it also have 4 times the absorption rate, 3 times the mineral content, 4 times cavity, and 10 times the surface area compared to the wood charcoal. Moreover, the surface area is larger if you compare it to carbon nanotubes. And bamboo biochar also have a few size, which is micropore, mesopore, and macropore. And in the novelty of this research, it is to reduce the time, energy, and cost of the production of this activated carbon by using appropriate carbonization technology, which is a self-sustained technology. We want to see if the self-sustained can reduce the cost by time and also energy. For my research methodology, would start by preparing the raw bamboo feedstock for our self-sustained carbonization. So for self-sustained carbonization, you need to cut it to 1 feet length. But before you do characterization and evaluation, you need to grind it to fine powder before you do undergo this analysis. Then from this self-sustained carbonized biochar, bamboo biochar, you undergo carbonization, which is actually this one is a chemical activation, where you have 2 parameters, which is the time and temperature. And here you impregnate it with phosphoric acid, 5:1 impregnation ratio for 24 hours, and dry it inside the oven. And then after you do the chemical activation, you will filter it and neutralize, washing until the pH becomes 7, because this one is acidic, so we need to neutralize it to pH 7. And then you do all of the analysis to select the best quality of bamboo biochar, where you have optimum activation parameters. And here we're doing the kinetic modeling of long-wave Wenelish absorption capacity by synthetic ammonical nitrogen removal jar test by having 3 parameters, which is temperature, mass dosage, and initial concentration. And lastly, we choose the best parameter for optimized activated carbon for treatment for agricultural wastewater, where we will evaluate the pH, COD, BOD, turbidity, and ammonical nitrogen. In my research methodology, this one is the first one, where in my first objective, when I said you have to cut it into 1 feet, you cut it into 1 feet like this and dry it and feed it inside the self-sustained reactor. And before you send for this analysis, you need to grind it until it's very fine powder. This is self-sustained reactor. This is after where not all of it is it's carbonized fully. And then this is my research objective 2. From this self-sustained biochar, we'll do the control chemical activation, where we have 2 parameters, which is time and temperature, and then we'll do the BT analysis to select the best optimum quality. So you will using the same characteristic to decide the best quality of optimum activated carbon. Here in the chemical activation, we'll take the self-sustained bamboo biochar, where we will put it inside a split tube glass furnace, quartz furnace, where we control the temperature and time, and at the same time we chemically activate it inside this furnace, where then we select the best of it using BT analysis. And then we'll do now this one is the way we chemically activate the bamboo biochar, where we have 5:1 ratio, and we dry at 105 degrees Celsius. And here is the machine that I use, okay, where we will put the bamboo biochar inside here to be heated at the temperature that's mentioned here for the activation temperature, and then we'll do the activation time after getting the characteristic analysis. Okay, here is our my second research objective, where we will do proximate, ultimate, surface morphology, and functional group. And here is research objective number 3. Okay, when the best activated carbon has been obtained, need to do the jar test using 3 parameters, which is temperature, mass dosage, and initial concentration. When we will produce the CE and QE, and we will do the kinetic Langmuir isotherm model. Okay, here is the temperature that I'll be using, 10, 20, 30, 40, with this fixed parameters. Okay, and also for the mass dosage, we're having 4 mass dosage, and for initial concentration, I have 1, 2, 3, 4 initial concentration. Okay, this is how we would analyze the jar test. Okay. Yes. So for the kinetic study, we will do 5 hours, which is 15, 30, 40, 5, 60, 75, 90, 120, 150, 250, and 100 minutes. Okay, we will take the concentration at this time. Okay, this is the kinetic modeling, where we will compare the QE in the experimental and the QE that is calculated by the plot graph. The last research objective, which is research objective number 4, I will use the best activated carbon with the best parameters from the kinetic study to do a jar test of 100 milliliter of agricultural wastewater, and I will compare the before and after to see for the removal of efficiency. Okay, and also to compare to see that if this bamboo activated carbon can produce filtered water that comply to the INQS standard of class 2A. Okay, and for this is analysis for my 4th research object. The data collection that's shown here is the data that I've collected from the start of my PhD journey until now. Okay, and here, okay, I've done proximate, ultimate, and pro-characteristic surface functional group and methylene blue absorption test with this raw Dendrocalamus asper, self-sustain, and actually I've done the control carbonization. Okay, but this control carbonization surface modification, when we did the BET surface area testing, it came out very low, which is 30 plus, so we have to change our methods. So now I did get the one that is chemically activated, the BETs for this surface area, as what do you call that, confirmation of the data. Okay. So this one, ammonium nitrogen adsorption test, I haven't done it with my activated carbon, but I've done some of the kinetic studies on this ammonium nitrogen absorption test using mass dosage here in UiTM Samarahan 2, where me and my degree student, we did the mass dosage, where we chemically activate this Dendrocalamus asper to see how the mass dosage absorption capacity and the percentage of removal for here. And here data collection for water quality efficiency test, it haven't been done because the activated carbon is not yet ready, so it cannot be done for my fourth objective. Okay, this is my data collection for ultimate analysis. I think I've presented it before. Okay, for this I also have presented this where I get this ultimate analysis for Bambusa and proximate analysis also. I've done it and I've reported it since last progress report. And also I've done this comparison from raw to self-sustain. And okay, here is also the same images where they have for raw asper they have a micropore only, and same upper also. For my data collection, okay, this one is my data collection since February. I think the last time that we did the progress report. Okay, for the BT surface area, I've done for the raw and for the self-sustain. Okay, so here, okay, the first one is this. Okay, this value, like I said just now, I've done the control carbonization. So when we did the control carbonization, the BT surface area is very low. So when we change our methods, which means that we did not do surface modified, we do chemically activated with phosphoric acid and potassium hydroxide. So I want to see is it really the methods or the chemicals that is not suitable to produce a high surface area. So when we check, yes, phosphoric acid have a higher chemically activated BT surface area compared to potassium hydroxide. So we will be using phosphoric acid with the same impregnation ratio, but it's just that we're going to what do you call it, carbonize it. Instead of carbonize it, we will activate it inside the furnace with the acid. Okay, so now I'm doing my experimental work for this chemically activated where I'm still in my first parameter, which is the temperature. I think I've gone to 700 degrees Celsius for all of my samples. And okay, here is the analysis that I've done. Okay, and here, okay, where I've already got the result, and I think we're going to send it again lah, for all of other the self-sustained for Bambusa. Okay. Okay, for my Gantt chart, okay, supposedly now it is the second quarter of okay, it's getting on third quarter of 2023. So supposedly I finished my kinetic studies, okay, according to this Gantt chart, but because of the what do you call that, the machine broke down and I'm unable to do the experiment there. So and I resort to a new method. So maybe this objective number 3 is going to be pushed until the end of this year. And for number 4, yeah, in the early of next year I will start doing the kinetic study here in UiTM Samarahan 2. Then we will continue until the fourth quarter lah, to do the performance evaluation of this TSS, COD, BOD and total nitrogen studies. Okay. Okay, status of publication. Okay, now I already sent one of my review paper with my co-author, and he is still marking and editing. And actually I'm also, because now I am actively participating in a conference, in what you call organizing a conference, so maybe I will send one of my papers to with my supervisor to the conference. Okay. Okay. And status of thesis writing. Okay. Okay. I'm still waiting in compiling the result for experimental and for journal publication, discussion and comparison with literature, and I have not started my thesis writing. Now I'm starting to write a paper with the data that I have and try to make the best of it of the data. Although my data is not complete for most parts, okay, especially the BET analysis, and so I think I've sent some of my samples to the TGA and still awaiting some analysis. Okay, planning for next semester. Since my methods of control carbonization surface modification did not produce the result that have significant changes from the self-sustain, I had to change my methods to chemically activated. So I'm going to FKK this 28th of August to finish the carbonization of activated carbon in objective 2. Then I will be sending all of the samples for characterization. And these base bamboo activated samples, I will analyze it for proximate, ultimate, the BT surface area, the SEM imaging, and the FDR analysis. And the best bamboo activated samples, I will be bringing most of it to UiTM Samarahan 2. Actually, by at the end of this year, we are going to get a new machine, which is the same split tube furnace, quartz furnace, to UiTM Samarahan 1 under my supervisor. So I can do the, what do you call that? I can do all of the chemical activation there in UiTM Samarahan. So I don't have to go back to FKK Shah Alam to do this mass production of these activated samples. Okay. Last but not least, thank you for listening for my video progress report, and I'll see you next semester. Thank you.